Now that we have our new definition, we can put my claim that we can find the trigonometric functions of any angle to the test. So to start off, let's see if we can find the sine of 120 degrees. So to do that, I'm going to start by visualizing the angle. Right? I'm going to draw the initial side where it always is, right on the positive x-axis, and the terminal side is going to be going this way. Right, so this angle here is more or less 120 degrees. Okay, now the sine of this angle will be the y coordinate of this point. Right, so to find this value, I'm going to draw a line down to the x-axis. Now, this angle, the acute angle made by the terminal side of our angle and the x-axis, it's got a name. That's what I'm referring to down here. This is what we mean by a reference angle. It's the acute angle made by the terminal side of the original angle and the x-axis. For our 120 degree angle, this angle is going to be, running out of room a little bit, is going to be 60 degrees. Now, here's the key part. This triangle here, the one made by the x-axis, the terminal side, and that extra dashed line that I drew, is a 30, 60, 90 triangle, just like the one that we used to find the sine and cosine of 60 degrees several lectures back. Based on those calculations, I know that this distance is 1/2, and this distance is the square root of 3 over 2, right? So that means that the coordinates of this point are -1/2, comma, the square root of 3 over 2, which makes the sine of 120 degrees equal to the square root of 3 over 2, the y coordinate of that point. All right, now suppose that we wanted to find the cosine of 120 degrees. Well, we've already done all the legwork. The cosine is just the x coordinate of this point, which is -1/2. So from this calculation, you can see the key point that we're going to use to calculate the values for non-acute angles. The values of the trigonometric functions for a non-acute angle are the same as the values for the corresponding reference angle, give or take a negative sign. So to find something like the secant of 30 degrees, or the cosecant here, we're going to use a method that we'll see repeatedly throughout the rest of the class. Rewrite it in terms of the sine and cosine. So the secant of 330 degrees is the same as 1 over the sine of 330 degrees. And let's see, 330 degrees, that's a fourth quadrant angle. So I'm going to draw my initial side in the customary place, and I'm going to go around to the fourth quadrant. The angle is going to look like this. So there is my 330 degree angle. Now, I'm looking for the coordinates of this point. So I'm going to kind of fill in my right triangle here. And this angle here is my reference angle. That's going to be 30 degrees, right? The whole circle is 360, so that one's going to be 330. That means that the coordinates of this point here are the same that we would get from the cosine and sine of 30 degrees. So let's see, that makes this point the square root of 3 over 2, comma, 1/2, and you notice I'm leaving some space there, right? Because now all we have to do is correct the signs based on the quadrant. The x coordinates in the fourth quadrant are positive, so the x coordinate will stay the same, but the y coordinate will become negative. Now I can answer the question. This makes the sine of 330 degrees equal to negative 1/2. So the cosecant is 1 over negative 1/2, which is negative 2. So this is a little different. Right now I'm looking for angles rather than sines and cosines. Now for an angle to have a cosine of negative 1/2, the x coordinate of the point where it crosses the circle has to be negative 1/2, which is over here. Remember this is a unit circle, right? So the distance all the way from the origin out to the edge of the circle is 1. So negative 1/2 is going to be here, right in the middle. And there are 2 points on the circle. One here and one down here, whose x coordinates are negative 1/2. Okay, so I'm going to get 2 angles, right? Hopefully you're seeing that. I'm going to get 2 angles here. And if I draw this angle in, whoops, try that again. If I draw this angle in, okay, this is the distance here is negative 1/2, which means this is going, my reference angle is going to be 60 degrees. And that means this angle, the one that I'm actually looking for here, is going to be 120 degrees, right? Because the two of them together make up a straight line. Straight line is 180. Okay, so how about the other one? Well, let me clean up a little bit here. Let me take my negative 1/2 out. All right, so my other angle is here. Now, let me clean up a little bit more. Take this out. There we go. All right, so we can just focus on this one. Now, this reference angle is going to be 60 degrees. Right? So the distance from my terminal side around to here is 180. Then I have to go 60 more. Right? So this angle altogether is going to be 240 degrees. So there's my answers. Right? There are 2 angles. One is 120 degrees. The other is 240 degrees. All right, so take a look, right? See if you can't think through this one. Talking about a tangent here, and see what you come up with. All right, so tangent of 1. Well, I know, just because you may still have that table sitting in front of you that we put together, right? I know that a 45-degree angle has a tangent of 1. So there's one answer. Just the positive ones, we can get at least one of the angles just by looking at the chart or the table that you're using. Okay, now, what's special about this? Because I'm always thinking in terms of this intersection here, right? The sine and cosine. When the tangent is 1, the sine and cosine have to be the same. All right, so I know wherever my second angle ends up, it's going to have a reference angle of 45 degrees, right? So it's going to be here, or here, right? Both of these angles being 45. Those would be the reference angles. Or it's going to be down here, and that would be my 45-degree reference angle. Now, let's think about sines, right? I know I want the tangent to be positive. That means that the sine and the cosine have to have the same sign. Either they have to both be positive, like they were in the first quadrant, or they have to both be negative. The only place they're negative is here, down in the third quadrant. Okay, so that's the one that I'm interested in. It's not this one. Let me clear that out. And it's not this one here. Right, so what's my angle then? This is the one that let me make it solid. That's the one that I'm looking for. And the measure of this angle from the initial side all the way around to that terminal side is 180 degrees, the full circle, plus the 45-degree reference angle. So it's going to be 225 degrees. So I get two answers, 45 degrees and 225 degrees. Okay, so hopefully you're seeing this business of identifying the sign, not the trigonometry sign, the plus or minus sign. This business of identifying the sign of the number is really important, and it's driven by the quadrant that our angle is in. So let's see if we can summarize this. Right? In the first quadrant, the x coordinates are positive and the y coordinates are positive. That means that both the sine and cosine are both going to be positive. Now over here in the second quadrant, the x coordinates are negative and the y coordinates are still positive. So over here, the sines are still positive, and the cosines, on the other hand, are negative. In the third quadrant, both numbers are negative, both coordinates are negative, so both the sine and cosine will be negative. And then finally, in the fourth quadrant, the x's are negative, the x's are positive here, the y's are negative, so the sines are negative and the cosines are positive. And then from this, we can infer what the tangents are, right? Because the tangent is the sine divided by the cosine. In the first quadrant, the tangents will be positive. In the third quadrant, the tangents will be positive, right? Because we're dividing two negative numbers. In the second and fourth quadrants, the tangent is a positive divided by a negative, which will be negative. And in the fourth quadrant, the tangent is a negative divided by a positive, which is negative. It's helpful to have those numbers handy. All right, just as a quick reference, because again, this is one of these things that's going to come up over and over again throughout the course of the class. All right, in the next lecture, we're going to take this concept a little further and see how, if we just know the value of one trig function for an angle, we can turn around and find the values for all of the other trig functions.